Hello students, in this session let us learn what is overtaking side distance or OSD, the requirement of OSD and how the OSD will be determined. So we'll first learn what is the requirement of the OSD. So if all the vehicles travel at the design speed, absolutely there will not be any requirement for overtaking operation. So sometimes if any slow moving vehicle encountered in front of you, it is very much essential for us to overtake the slow moving vehicle and proceed further. So now the adequate distance must be visible to the vehicle overtaking the slow moving vehicle before colliding with any vehicles in the opposite direction. So thus, the minimum overtaking side distance visible ahead of the driver for safely overtake the slow moving vehicles, that we call it as the overtaking side distance. That minimum distance will depend upon the speed of the overtaking vehicle, the speed of the overtaken vehicle, and also some of the side distance consideration. So now when we measure the overtaking side distance, even as we discussed in the previous session, here also similar to the SST condition, height of the driver's eye level is taken as 1.2 meters above the road surface level, and object in case of the SST determination we have taken it as 0.15 meters above the ground level, but when we compute the OSD we will consider the height of the object as an height of the vehicle, and it will be considered as the 1.2 meter above the road surface. So for measuring the overtaking side distance, some of the factors which is essential to consider. The factors on which OSD depends upon the speed of the overtaking vehicle and overtaken vehicle, and also the vehicles that are coming in the opposite direction, if any. And also the OSD depends upon the clear spacing between the vehicles, that is nothing but the spacing between the vehicles, which in turns that will depend upon the speed of the vehicle. It also depends upon the skill and reaction time of the driver, rate of acceleration of the vehicles, and the gradient of the road, if any. So now we'll analyze how the overtaking operation will be taken place, and for the determination of the overtaking side distance. So now let us consider we have the two-lane road here, lane 1 and lane 2. Okay, so it's a two-lane, two-way vehicle. So you can see the vehicles that are there in the both the direction. Let me take the vehicles which are in the maroon, or the fast-moving vehicle which is required to overtake the slow-moving vehicle which is in the red color, and the vehicles which is coming from the opposite direction are in the other lane, or the indicated in the green color. So now what we will, let us consider that the vehicle A, that is nothing but the one which is required to overtake, is initially traveling at the design speed v meter per second or v kmph. It is required for the fast moving vehicle which is traveling at the design speed to overtake the slow moving vehicle which is traveling at the reduced speed, that let us consider that as VB meter per second or capital VB kmph. So when the vehicle has, the fast moving vehicles overtake the slow moving vehicle, what it generally do, the first vehicle A accelerate and it shift to the adjacent lane, and then it comes back to the original lane to complete the overtaking operation before the vehicles come in the opposite direction approaches the overtaking stretch to avoid. So if this happens, there will be we can consider that there is a safe overtaking operation. So for the analysis purpose, overtaking operation can be split up into the three operation. So you can see here the first is the distance d1, second is the distance d2, and the third is the distance d3. So now we'll understand what is d1, d2 and d3. So let d1 is the distance traveled by the overtaking vehicle A during the reaction time of the driver while the vehicle move from A1 to A2. That is nothing but, so while the driver vehicle A, the driver of the vehicle A, he decides during the total reaction time to overtake the slow moving vehicle. So during that reaction time, a vehicle A will travel to certain distance and position changes from A1 to A2. That distance traveled by the fast moving vehicle during the reaction time, that is known as the distance D1. So once the driver decides to overtake, what he will do? The fast moving vehicle accelerate, shift to the adjacent lane and overtake the slow moving vehicle and come back to the original lane. So this distance we call it as the D2. The D2 can be further split up into S, B and S. So now S is the distance between the fast moving vehicle and slow moving vehicle before overtaking, while the vehicle A2 is waiting for an opportunity to overtake the slow moving vehicle. And during the overtaking operation, the slow moving vehicle will also travel to the certain distance. That distance is measured as B. So after that, the vehicle overtaking operation is done. The fast moving vehicle shift to the adjacent lane and maintaining some distance between the slow moving vehicle, that once again can be taken as the clear spacing. Yes. And during this overtaking operation, the vehicles which are in the opposite direction will move to a certain distance. The distance traveled by the vehicle in the opposite direction during the overtaking operation is determined as the distance D3. So now let us see. So for the two-way line, the total overtaking distance will be D1 plus D2 plus D3 in meter. So if you have a single lane vehicle, if you don't have any vehicles that are coming in the opposite direction, the value of D3 becomes 0. Thus overtaking distance will be just D is equal to D1 plus D2. That will be for the single lane road. So now let us see how all the three distance D1, D2, D3 will be calculated. So the analysis of OSD will be done based upon the some of the assumption. The first assumption that the overtaking vehicle A is forced to reduce the design speed from the design speed V meter per second to V meter per second. That is nothing but the speed of the slow moving vehicle, and the fast moving vehicle will be traveling behind the slow moving vehicle, allowing the space S till there is an opportunity for safe overtaking operation. When the driver A finds a sufficient cleared gap ahead, he decides to accelerate the vehicle and overtake the slow moving vehicle B, during which vehicle A moves at the speed of slow moving vehicle through a distance D1 from position A1 to A2. The vehicle accelerates and overtakes the slow moving vehicles within the distance D2 during the overtaking time T between the position A2 to A3. The distance D2, the overtaking distance T2, is split up into three parts, that is the spacing S between the A2 and B as we saw in the previous slide. Distance B meter that's a distance traveled by the slow moving vehicle between B1 to B2 during the overtaking operation, and spacing S after the overtaking operation, that's a space maintained between the slow moving and fast moving vehicle at the position B2 and A3 respectively. And the last assumption is during the overtaking operation, the vehicle from C, which is coming from the opposite direction, also travel to certain distance D3 from the position C1 to C2. And now the determination of OSD. So to determine the OSD, we have to compute what is the value of D1, D2, D3 has to be determined. So now it is seen that the first is the vehicle during the overtaking operation. The vehicles which is from the position A1 to A2, it will travel to some distance. Okay, so this is what is the distance traveled by the vehicle during the reaction time of the driver. So if we consider reaction time as T, at this time, so we have already learned in an assumption that it is assumed that fast moving vehicles forced to reduce the speed to the speed of the slow moving vehicle till it find an opportunity to overtake. So that's why the distance d1 is can be calculated as the distance traveled by the vehicle during the reaction time t at the reduced speed of slow moving vehicle, that is VB meter per second. So generally for the computation of the OSD, we can take the value of T value as 2 seconds. Next is after the during the overtaken operation, the position vehicle from position A to vehicle start accelerating and it shift to the adjoining lane and it comes back to the previous line. That is the total D2 distance will be the S plus B plus yes. Okay, so this is this we have already looked into the pictures. What is yes and B is nothing but the distance traveled by the slow moving vehicle during the overtaking operation, and S is nothing but the clear space between the vehicles. So now the first we need to compute the what is yes, what is B, and the time taken for the overtaking operation. The clear spacing can be determined using an empirical formula. S is equal to 0.7 VB plus 6, where VB is the speed of the slow moving vehicle. And the T, what is the time required for the completion of the overtaking operation, is termed as the capital T. And this distance can be determined as, so we have an expression T is equal to square root of 4s divided by a. Using this relationship, we can determine what is the time required for the overtaking operation, where s is nothing but the clear spacing and a is the acceleration of the vehicle. Once we determine the value of t, so we can estimate the d2. So d2 is nothing but b plus 2s. B is nothing but the distance traveled by the slow moving vehicle during the reaction time t. So that is what is indicated. T is the for during the overtaking time t, the distance traveled by the slow moving vehicle. The speed of the slow moving vehicle is VB meter per second. So the B can be estimated as B is equal to VB t. Okay, so plus 2s. So s can be computed using the empirical formula, and to determine the overtaking time we have an expression. First find out what is t and s, and then substitute in the d2 value to get the what is the distance traveled by the vehicle during the overtaking operation. Meanwhile, it is required for us to calculate the distance 3, that is nothing but the distance covered by the vehicle in the opposite direction during the overtaking operation. So that is like what is the distance traveled by the vehicle in the opposite direction during overtaking time t. So now it is also assumed that the vehicles in the opposite direction is also traveling at the design speed v meter per second. Thus, D3 will be Vt into T. So, substitute all those things. OSD can be taken as D1 plus D2 plus D3. Okay, this is for the two-lane, two-way condition. And for the, if you convert it to the meter per second, the formula changes to 0.278 VBT. So, 0.28 or 0.278 is the conversion factor from meter per second to kilometer per hour. So using this expression, you can compute what is the OSD value. And in some other case, we will not be having the details of overtaken vehicles. The slow moving vehicle will not be available with us. In such cases, we can assume the speed of the overtaking vehicle as V minus 4.5 in meter per second. If you are computing in terms of the kmph, the speed of the overtaking vehicle can be taken as V minus 16, where V is the design speed. So the table here will gives you the details about what is the overtaking distance and the acceleration. So the acceleration of the vehicle, if the design speed is 25 kmph, so overtaking maximum acceleration will be the 5 kmph per second. So here if A value is not available, you can take A value from the values recommended by the IRC. And you can also note that for one-way road, the OSD will be just D1 plus D2. D3 will be there only when you have vehicles from the opposite direction. If vehicles from the opposite directions are not available, OSD will be just D1 plus D2. And it is to be noted that it is desirable to construct highways in such a way that the length of the road visible ahead at every point is sufficient for the safe overtaking operation. But it is sometimes not practicable, and there are some stretches where the safe overtaking distance cannot be provided. In such zones where overtaking or passing is not safe or it is not possible, suitable signposts should be installed indicating that no passing or overtaking is prohibited before any such restrictions are made. However, those conditions, overtaking opportunity for vehicles moving at the design speed should be given at the frequent intervals as possible. These zones meant for the overtaking operations are called as the overtaking zone. The minimum length of the overtaking zone will be can be taken as 3 times the OSD, and the desirable length of the overtaking zone will be 5 times the OSD. So you can, this picture here will represent the how the overtaking zone looks. So now you can see here this is original width of the road W. So at some portion where it is not possible for you to provide the safe overtaking, then at some position the opportunity will be given for the overtaking by increasing the width of the road W1. So now this length at which you have provided widened the road for the purpose of the overtaking operation, that we call it as the overtaking zone. So the length of this overtaking is, it is minimum should be 3 times the OSD and desirable to have up to 3 times the OSD. So now here you can see the suitable signboards are provided where SP1 on both the side indicates that the start of the overtaking zone, whereas SP2 indicates the end of the overtaking zone. So like this, whenever it is not possible for you to provide the overtaking side distance, wherever it is required at frequent intervals as possible, we have to provide this overtaking zone. With this, I'll conclude. In the next session, we'll take some examples and we'll see how the OSD will be determined. Thank you.